Today we are exploring the trends of the periodic table. So I have this very cool 3D animation site from Google, and it basically shows you the different elements. So this is what is known as elements. You have a total of 18 groups, so you can do your calculations. So groups go from top to bottom. So group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, all the way to group 18. We also have here in total 7 periods. 1, 2, 3, 4, 5, 6, 7. Periods go across from left to right. The general idea of how elements are being arranged is through the atomic number. As you may recall, atomic number is the number of protons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how elements work is that if I look at H, I know that anywhere, any part of the world I go to, H always stands for hydrogen. Ne always stands for neon, K always stands for potassium, He always stands for helium. And the good thing is that because this is universal, even if you don't speak the language of the country that you're in, the elements will always be the same. The atomic number doesn't change for that particular element. So if I'm going to click on, let's say, lithium, as you can see here, so this is how lithium looks like. Because it has an atomic number of 3, it has a total of 3 protons, and because it's neutral, it has a total of 3 electrons. So you can see the nucleus contains the neutrons and the protons surrounded by the electrons. So there's a lot of properties associated to that you can have a read about. So lithium, as you may be aware, is a metal, it's an alkaline metal. If I go to something across, let's say fluorine, fluorine here has an atomic number of 9. It has a total number of protons of 9, which means it has a total of 9 electrons. And if you look at fluorine right here, it's a non-matter. You can see that? It's a non-matter. So you could sort of predict that most of these non-matters are located towards the right of the periodic table. Most of the matters are located towards the left of the periodic table. If I go to an element that is towards on group 18, let's say I click on argon, it's known as noble gas. As you may be aware, noble gases are unreactive because they are stable. So in this case, it has a total of atomic number of 18, which means it has 18 electrons. And if I look at how this atom is being arranged, it has 8 electrons in the outermost shell, which means it's stable. If it's stable, it is not reactive. It doesn't react with anything else. That's the reason why group 18 elements are stable and they are not reactive. So by looking into the properties of the elements, we can tell the different properties of the elements based on the number of electrons that it contains, the arrangement of the electrons, something known as the electronic configuration, which is how electrons are being arranged in the atom. And you can see that most of the elements with the same properties will be located in the same group. So if I go into group 1, elements such as lithium, sodium, potassium will have the same properties. Or in this case, fluorine, chlorine, bromine, group 17 elements will have the same properties.